This video is about properties of parallelograms.
So next in this chapter, we're going to talk more specifically about quadrilaterals, which are four-sided polygons. We're going to start by learning about the special quadrilateral called a parallelogram, which has two pairs of parallel sides. So that's what makes something a parallelogram, two pairs of parallel sides. And you can see on this figure that the opposite sides are the ones that are parallel to each other, and that's shown with the arrow. So a single arrow shows that it's parallel to the other single arrow, and the double arrow shows that it's parallel to the other double arrow. One of the properties that you're going to need to know about parallelograms is that opposite sides are also congruent. So not only is AB parallel to DC, but they're also congruent to each other, which means the same length. We could write that in two ways. We could say that AB, the segment, is congruent to DC, the segment. And notice they both have the segment symbol above with the congruent symbol between. Or we could say AB equals DC. Now, without the segment line above, it's referring to the length of something. So the length of AB is equal to the length of DC. It's just a different statement. So you want to be careful to use congruent when you're talking about segments, but an equal sign when you're talking about lengths. And then you can also say the same about BC being congruent to AD. Or you could say the length of BC is equal to the length of AD. So if this was 15, this would be 15. If this was 8, this would be 8. For example, knowing that this is a parallelogram, can we find x? So in parallelograms, opposite sides are congruent to each other, so we can set up the equation, x plus 2 equals 2x minus 3, and then solve for x. Easy as that. Another property, this one's about angles, is that the consecutive angles in a parallelogram are supplementary. Supplementary means adds up to 180. Consecutive means right next to each other. So just like the numbers 3, 4, and 5 are consecutive. Angle A is consecutive with angle B because they're right next to each other. They add up to 180 in a parallelogram. So A plus B has to equal 180, as would D plus C. And you know that parallelograms are quadrilaterals, which are supposed to add up to 360 degrees. So sure enough, 180 and 180 would make 360. Or you could do angle B plus angle C. That must also be 180. So any pair of consecutive angles in a parallelogram will add up to 180. So if you know that this is 70 degrees, you actually know all of the other angles in this figure. This would have to be 110 because consecutive angles are supplementary. Now B is also consecutive with C, and since those have to be supplementary, that means that this one is 70. And that would mean that this one is 110. And by filling that in, now we've discovered the next property, which says opposite angles are congruent. So this time we're talking about not consecutive angles, which are right next door to each other, but going across the figure, and those are going to be congruent to each other. So we had it labeled with this as 70, and we discovered that this one was also 70. So in a parallelogram, opposite angles are congruent. And then another property is that the diagonals of a parallelogram bisect each other. So diagonals are the segments that go from a vertex to an opposite vertex, so right through the figure. And bisect means cut in half. So the segment AC, when you go right through the middle of this figure and connect A to C, is cut in half by the segment that goes from B to D. Same thing, the segment from B to D is cut in half by the segment AC. So we end up with, if you label the point in the middle point E, then you can say that BE is equal to DE, right? And AE is equal to CE. So each of the segments in the middle, or I guess I should say each of the diagonals has been cut in half by the other diagonal. Let's see that with numbers. So here, knowing that this is a parallelogram, we can write equations to find x and y. Ln is one of the diagonals and Km is another. We know that each of the diagonals has been bisected, so we're going to write two equations. This one has to equal this one because that one has been cut in half. Put an equal sign there. And the second equation we have is that this one has to equal this one because that has also been cut in half. Now the diagonal Km has no bearing or relationship to the diagonal Ln. All we know is that each one has been cut in half. Well, now I have two equations with x and y in them. So I have to use either combinations or substitution method to solve this system of equations. I'm going to use substitution method because I already have x by itself. So I can just put this inside of the other equation, extend the page a little bit here. Y plus 10 equals 2, parentheses, y plus 2 minus 8. So I've replaced x with y plus 2. Finish solving this example by getting y by itself. Let's put everything on the left and get y on the right. So I've discovered that y is 14, and then I'm going to have to plug that back in. It's easiest to plug it in here to figure out x. X is going to be 14 plus 2, which is 16. You could always plug them back in to check that now each of the diagonals has actually been bisected. So sure enough, if I plug in x as 16 and y as 14, I'm going to get the same value for LP as I am for NP, and then I'm going to get the same value for KP as I am for MP. And that is all.